navigating between the different iOS command modes. In this video, I'll look at the commands that are used to move between the different iOS command modes. We'll look at the enable command, the disable command, configure terminal, exit, end, Control Z on your keyboard, plus some sub-mode or sub-configuration mode commands to enter the different sub-modes. Let's take a look at how this works. I already have a console connection to a 2960 series switch. I'll press enter on the keyboard, and now I move to user exec mode. Notice the command prompt. To get to privileged exec mode, I type enable. To return to user exec mode, I type disable. I'll return back to privileged exec mode. Now, to get to global configuration mode, I type configure terminal, and now I'm in global configuration mode. I can type exit to return to privileged exec mode. If I type exit again, I leave the console altogether. So I'm in privileged exec mode. I type exit, and you can see I've left my console connection. To re-enter the switch and get a command line interface, I have to press enter on the keyboard, and I'm brought back to the console connection with the switch. I'll type enable, configure terminal, and now I'm in global configuration mode. Let's enter one of the sub-configuration modes. I'll type line console 0 to get to the management interface for the console port. Now that I'm in a sub-configuration mode, if I type exit, I return to global config mode, like this. I'm back in global config mode. This time I'll type line VTY 0 to 15 for my virtual terminal management interfaces. I can move directly from one sub-configuration mode to another. Notice if I type interface VLAN 1 from within my line VTY line configuration mode, it'll take me directly to interface configuration mode. From here, I can enter different interfaces like interface fast Ethernet 0/1, or I can move directly to line console 0 again. Commands that are normally run in global configuration mode can also be run from any of the sub-configuration modes as well. The end command and the Control Z keyboard combination essentially do the same thing. They return us all the way to privileged exec mode. Let's give it a try. I'll type end, and you can see that I'm moved all the way to privileged exec mode. I'll move all the way back to global configuration mode, into line console 0 again, and this time I'll use my keyboard, hold down the control key and press Z for Control Z, and you can see that I'm brought all the way back to privileged exec mode. If I'm in global configuration mode and I type end, I'm also brought back to privileged exec mode. So that covers the enable command, the disable command, configure terminal, exit, end, and Control Z. Navigating efficiently between the different command modes will save you a lot of time. The Cisco iOS help command is accessed by using the question mark. The help command is context sensitive. The Cisco iOS help command is accessed by using the question mark. The help command is context sensitive, so it matters how and where you use the question mark. For instance, let's say I want a list of all the commands that are available to me in user exec mode. I simply type a question mark and I'm returned the commands that are available in user exec mode. If I type enable and enter privileged exec mode and put in a question mark, I'm given the commands that are available to me in privileged exec mode. I'll press the space bar to get the next page of output. An even different set of commands is available to the user in global configuration mode. Notice I'll go to global config mode, put in a question mark, and I'm given a completely different set of commands that are available in this particular command mode. There are other uses for the help command as well. Let's say that I don't want a listing of all of the commands that are available, and I just want help finishing one particular command. For instance, let's say I'm putting in the command interface, but I've forgotten what the complete command name is. I've typed in, and I need help finishing the command. I can put in part of a command, and then put in a question mark, and it'll help me finish the command. Notice that I put in and then a question mark, and the help command has returned that the command that I'm looking for is interface. I can use the help command in another context as well. So now that I know that the command is interface, let's say I'm not sure what the next command parameter or argument is that goes with the interface command. In this case, I'll put a space and then a question mark, and it'll tell me the next parameter or argument that is required by the interface command. Now I know that the next part of the command is either the name of the interface like Ethernet, Fast Ethernet, Gigabit Ethernet, or maybe it's VLAN or range. Related to the help command is the command syntax checker. The command syntax checker will let me know when I have a problem with the command that I've put in. For instance, we can see here that the next part of this command would be one of these arguments here. Let's say I make a mistake and I type in the number 33 instead of VLAN or range and hit enter. Notice that the command syntax checker has informed me that beginning at the number 3, I've made an invalid input. This is extremely useful because it helps me to isolate where the problem is with the particular command that I've entered. This can work in different contexts as well. For instance, let's say that I've put in just the letter I instead of interface and I hit enter. The command syntax checker informs me that the letter I is an ambiguous command. The reason being is that if I type in I and a question mark, there's actually two commands that begin with the letter I in global configuration mode, the command interface and the command IP. The third example of the command syntax checker is when I type in interface and hit enter, and the command syntax checker has informed me that the command is incomplete. To solve this, I put in interface again, a space and a question mark, and I'm given the next set of options that I need to finish this command. You can see how the help command is very useful in learning the different commands that are available to you, as well as the correct context and use of the different commands. Support for hotkeys and shortcuts makes the Cisco IOS extremely efficient. I'm using Packet Tracer 6.2. I have a console connection to a 2960 series switch. Instead of using the terminal emulation program to console into the switch, this time I'll click directly on the switch and go to the Command Line Interface tab and press Enter to get a command line interface. The first hotkey and shortcut that I'll talk about is the tab key, or tab completion, for automatically completing your commands. You can use it like this. To get to privileged exec mode, I would normally type the command enable. With tab completion, you simply type the first few letters of the command, in this case EN, and press the tab key on your keyboard, and the command is automatically completed for you. This is extremely useful. Now, this will only work if the first few letters are the prefix for only a single command. For instance, if I want to put in the command configure for configure terminal, and I type CON and press tab, you'll see that it doesn't work. The command isn't completed. The command isn't completed because there's more than one command beginning with the letters CON in privileged exec mode. To see that, I put in a question mark, and you can see that there's two commands that begin with CON, configure and connect. So if I want to use tab completion, I'll need to type CONF and then press tab, and you can see now the command is completed. For terminal, all I need to do is type the letter T, and there's only one command that follows configure, or only one argument that follows configure, and that's terminal. So I press T and hit the tab key, and you can see that the command and the parameter or secondary command is automatically completed for me. Even better than command completion with the tab key is command shortening. With command shortening, instead of pressing the tab key to complete the command, you simply use the first few letters of the command, and the iOS will automatically finish the command for you. So instead of typing INT and then pressing the tab key to complete the command interface, all I need to do is simply leave it at INT and move on with my command. This is extremely useful. For instance, instead of typing the command interface fast Ethernet 0/1, which is a very long command to type, command shortening allows me to shorten the command to just INT, F for fast Ethernet, and 0/1. The iOS automatically knows that the command that I'm trying to write is interface fast Ethernet 0/1, and it enters that command for me. You can see how useful command shortening is, and it will save you a lot of time. To cycle through your command history, you use your up arrow and down arrow keys. For instance, I'll use my up arrow, and you can see that the last command that I used was INTF 0/1, or interface fast Ethernet 0/1. Now, I've only entered one command in interface configuration mode, so there's not a lot of command history to cycle through. If I do a Control-C on my keyboard, which takes me back to privileged exec mode, and do the up arrow key, you can see that there are two commands in my history, and if I cycle through with the up arrow key, I go backwards in my command history, and if I use the down arrow, I go forwards in my command history. This is very useful for commands that are used repeatedly. Now let's take a look at some of the hotkeys. We already know that Control-Z will take us back to privileged exec mode. I hold down the Control-Z keys, and you can see I'm brought to privileged exec mode. Similarly, Control-C will also exit to privileged exec mode, and it can also be used to abort certain commands. For instance, if I type configure and T and then hit Control-C, the command is aborted. Control-A will jump the cursor to the beginning of a line. I'll type configure and do Control-A, and you can see that the cursor jumps to the beginning of the line. If I use Control-E, the cursor jumps to the end of the line. Control-Shift-6 is another useful key combination. Control-Shift-6 will interrupt a command midstream. Let's say, for instance, I mistype the command configure and press enter. The iOS is trying to translate the letters that I did type into an IP address. Instead of being stuck in this situation, I can simply press Control-Shift-6 and the command is aborted. To see Control-R work, I've consoled in to an actual 2960 series switch using PuTTY. I'll press Enter and you can see I have a command line interface. Control-R is useful for situations where you've typed a command and the switch or router receives an event and displays that event to the console, interrupting your command. For instance, I'll type enable, I'll get to global config mode, and let's say I'm trying to configure interface fast Ethernet 0/1. I've typed the command switch port mode, and I haven't finished the command when all of a sudden, let's say an interface comes up. So I'll plug in a cable to one of my interfaces. It'll create an event on the switch and we'll see that output is sent to the screen. There it is. You can see that one of the switch ports just came up right in the middle while I was typing my command. If I simply press Control-R on the keyboard, you can see that the command is retyped. I'll do it again, Control-R, and there's the command. This is really useful because now I can finish my command without interruption. So Control-R and redisplaying a line is a very useful key combination as well. One of the first things you'll want to do when installing a device on your network, like a Cisco series switch, is secure access to the device so only an administrator will be able to configure it or change its settings. To do this, we'll need to set some initial configuration settings to secure access. I'll click on the desktop PC and click on the terminal emulation program, and you can see that I now have a console connection to the switch. For this video, I'll use the command line interface directly on the switch. As you can see, I'm logged into the switch in user exec mode without any authentication. This is a security risk. An even greater security risk is that I can type the enable command and get to privileged exec mode also without any type of authentication or password. From privileged exec mode, I can begin configuring the switch, so the first thing you'll want to do is secure access to privileged exec mode. To do this, I'll go to global configuration mode and put in the command enable secret and then the password. You'll want to use complex, strong passwords whenever possible. Since this is a test case scenario, I'll use the password class. The secret parameter assures me that the password class will be encrypted in the configuration file. An alternative form of this command is enable password class. This form of the command does not provide encryption for the password within the configuration file, so I'll backspace out of the command. Let's see if our enable secret password class has worked. I'll do a Control-C to get to privileged exec mode and then exit the switch. Now I'll press enter. I'm in user exec mode. I'll type enable and you can see I'm asked for the password. When I type the password in, you won't be able to see any characters as I type. I'll type in class and press enter, and you can see that I'm now in privileged exec mode. Let's take a look at our running configuration up to this point. We can do this by typing in the command show running-config to look at our running configuration. I'll press enter. And you can see up here at the top, there's our enable secret command here. The 5 means that it's an MD5 hash, and this is a one-way hash of our password class. So you can see how the enable secret command obfuscates the password within the configuration file. To see the rest of your configuration file, you press the spacebar on your keyboard. Now we've encrypted the enable password or access to privileged exec mode, but what about access to simply consoling into the switch? We can secure that as well. To do that, I'll type enable, the password class. I'll get to global config mode with a conf t command, and I'll need to go into line configuration mode for line console 0. I'll type in line console 0, and now I'm in line configuration mode. I can now put in a password for my console connection. I'll type in password, and normally I would use a complex password, but for this demonstration I'll simply use the password Cisco and press enter. I'll type in the login command, which enables global admin login at line console 0. Now that I've secured the console port, I'll also want to secure virtual terminal access for remote logins. I'll type in line VTY for virtual terminal or virtual teletype, and then how many lines I want to allow remote access to. The Cisco switch is capable of 16 simultaneous remote logins through virtual terminals. To configure all 16, I simply type in 0 for the first terminal, a space, and then the last terminal that I want to configure. In this case, I'll put 15. This will allow me to configure virtual terminals 0 through 15. I'll put in password, Cisco, and then the login command. Let's take a look at these passwords in our running configuration. To do that, I'll do a Control-C to get to privileged exec mode, and then put in the command show run, which is short for show running config. I'll press the tab key and you can see the full command. So here's the running configuration file. I'll press the space bar and go down towards the bottom, and you can see there's the configurations for line con 0, line VTY 0 to 4, and line VTY 5 to 15. The iOS breaks up the virtual terminal lines into two groupings, 0 to 4 and 5 to 15. Notice the password Cisco is seen in plain text. This is different than the enable secret password, which has been encrypted through a one-way hash. We can add greater security to the switch if we can encrypt these passwords so that they're no longer visible in clear plain text. To do this, I'll go back to global configuration mode and put in the command service password dash encryption. This command will put a light level of encryption on all passwords on the switch. We can see this now if we go back to privileged exec mode, look at the running configuration file. I'll spacebar down to the bottom, and you can see that now the password Cisco has been encrypted with a type 7 encryption. This is not a very strong form of encryption, but it does add a layer of security. Another important initial configuration command for securing access to the switch is setting a banner message. To do this, I'll go to global configuration mode, and I'll type in the command banner MOTD for message of the day. Now I can put in a message that will be presented to users when they log in. This message will serve as a legal warning for unauthorized users, informing them that they are trespassing and legal action will be taken. I can now put in my security message. The message that I type will need to be between two delimiters. It's a good idea to use a delimiter that won't be a character within the message. For instance, I'll use quotation marks as delimiters for my message. In between the question marks, I'll put in the message, no unauthorized access allowed, violators will be prosecuted to the full extent of the law. This lets any would-be hackers know that they're trespassing on a secure device or secure network, and that this is a protected environment enforceable by law. I'll press enter, and the banner is set. And now let's observe some of these security configurations. I'll do a Control-C, type exit to leave the switch. I'll press enter. Notice that I'm presented with the banner warning, as well as a request for a password just to get access to the console. I'll put in the password Cisco, and now I'm in user exec mode. I'll type in enable. I'm now asked for another password to reach privileged exec mode. I'll type in the password class, and now I have full access to the switch. After you've begun some initial configurations on your switch, you'll want to know how to save your configuration. You can see that I'm using Packet Tracer and I have a command line interface to the switch. Notice the banner message and that I'm being prompted for a password. I'll put in the password Cisco, type enable, password class to get to privileged exec mode. I'll type in configure terminal to get to global config mode, and I'll set the host name of the switch to S1. To save the configuration on the switch, I'll go back to privileged exec mode by typing exit and pressing enter. And then from privileged exec mode, I put in the command copy running-config startup-config. This command means copy the running configuration to the startup configuration file. The running configuration is the currently working configuration that's running in RAM memory. The startup configuration file is stored in NVRAM memory. The difference is that RAM is volatile and NVRAM is non-volatile, so if you copy the configuration to NVRAM, it will be available when the switch is restarted or reloaded. So I'll press enter, and you can see that I'm prompted for the destination file name. The default name is startup-config, and you can see it between the brackets. I'll press enter to accept the name within the brackets. My configuration is now saved. I can verify the location of my saved configuration file by putting in the command dir for directory. I'll put a space and a question mark, and you can see that there's two different types of storage that I have access to: flash memory and NVRAM. Both of these are non-volatile. The flash memory holds the iOS operating system, and the NVRAM holds the configuration file. I'll put in NVRAM and a colon and press enter, and you can see there's the startup-config file. Now if I was to reload the switch or incur a power failure, my configurations will remain. I'll press the arrow keys on my keyboard and do an up arrow to go back to the command copy running-config startup-config. There's an easier way of typing this command with command shortening. Instead of having to type out running-config and startup-config, I can simply type copy run start, and command shortening will finish the command for me. If I reload the switch, I'll put in the reload command, proceed with reload, I'll press enter to confirm. We'll see that after the switch reloads that the host name will remain S1, and we should see the same banner message. You can see there's the banner message. I'm prompted for a password. This indicates that the configuration was saved, and the host name or device name shows up on the command prompt, also indicating that the configuration was successfully saved and reloaded upon startup. If I wish to erase the configuration, I'll type in enable, put in my password to get back to privileged exec mode. I can put in the command erase STA. I'll press the tab key to finish the command, and the full command is erase startup-config. I'll press enter, and I'm given a warning. Do I want to really do this? Do I want to continue? The default answer is confirm, so I'll press enter. You can see the message output to the screen indicating that the NVRAM has been altered, or in this case, erased. I can now reload the switch, and this time, upon reload, it should take us directly to the switch command prompt without any authentication required or banner message. I'll press enter, and you can see that I'm brought directly to the switch command prompt. The host name S1 is no longer there, nor banner message, nor line console 0 password required. Let's say I make some changes to the switch. For instance, I'll type enable and config T to get to global configuration mode, and I'll change the host name to my switch. You can see the device name is now my switch. I'll exit and save the configuration. So the running configuration has been saved to the startup configuration file. Now let's say I continue with some additional configurations. I get to global config mode and I set a line console 0 password to Cisco. I put in the login command, and let's say I change the host name one more time, this time to S1. Now I've made these changes. Now the current state of the switch is that it's running the latest configurations in running configuration. That means the latest configurations are running in RAM memory. Let's say I'm no longer happy with the configurations I've just added to the switch, and I want to go back to the last saved state. The last saved state is where the device name was named My Switch. I've changed it now to S1, but I haven't saved the configuration. I can revert back to the previous saved configuration by exiting to privileged exec mode and copying, in this case, not the running config to the startup config, but the opposite. I'll copy the startup configuration to the running configuration. This will load the startup configuration file into RAM and make it the new running configuration. I'll press enter and I'll accept the default, and you can see that the switch has changed names back to My Switch. The startup config was loaded into the running config. This does not completely erase the running config, but rather the configurations in the startup config will be merged into the running config. Knowing how to save your configuration and erase a configuration and reload the switch is an important skill to master. An access layer switch, like a Cisco 2960 series switch, is typically used as a layer 2 device, and therefore does not need an IP address to function correctly. The only reason for assigning an IP address to a switch is to be able to remotely manage it over the network. In other words, right now I can manage or configure the switch using a console cable and a terminal emulation program. But what if I want to configure the switch from another building or room on the network? In this case, the switch will need an IP address, and I'll use a protocol like SSH to establish a remote terminal connection. To assign an IP address to a switch, you assign it to a switched virtual interface, not to an individual switch port. In other words, the IP address will be assigned to a virtual LAN interface, in this case interface VLAN 1, which is the default VLAN interface on the switch. To do this, I'll go into the desktop PC, click on the terminal emulation program, click OK. You can see I have a console command line interface. I'll type enable to get to privileged exec mode, configure terminal to get to global config mode, and now I need to go into interface VLAN 1, which is the default switched virtual interface. I'll type in interface VLAN 1, and you can see I'm now in interface subconfiguration mode. I can now assign an IP address to the switch. I'll assign IP address 192.168.1.10 with a subnet mask of 255.255.255.0. Interface VLAN 1 is shut down by default. To activate the interface, I'll need to put in the no shutdown command. You can see the interface has now changed state to up. We can verify it in the running configuration. I'll do a Control-C to get back to privileged exec mode, type show run, and page down to the bottom of the configuration where you can see interface VLAN 1 and the IP address. I'll also examine some summary information about the interface by typing in the command show IP interface brief. Once again, I'll page down by pressing the spacebar, and you can see that the VLAN 1 interface 192.168.1.10 is physically up and logically down. It's physically up because we enabled it with the no shutdown command. It's logically down because none of the fast Ethernet switch ports that are assigned to VLAN 1 have come up yet, or are active or plugged in to any devices. If I minimize this window and take a look at the switch, only a console connection to the console port is running from the PC to the switch. Let's get an Ethernet cable and see if we can bring up one of these switch ports. I'll grab a straight through Ethernet cable and run it from the PC by clicking and dragging, and then I'll click on the switch and attach it to Fast Ethernet 0/1. Notice the Ethernet port on the desktop PC has gone green and is up, and the switch port Fast Ethernet 0/1 is in the process of coming up. I can fast forward time to speed up the process. I'll go back into the desktop PC and issue the command again. Up arrow, show IP interface brief, page down, and you can see that interface VLAN 1 is physically up, enabled, and now logically up because a switch port in VLAN 1 is now active. By default, all switch ports on the switch are assigned to VLAN 1. So interface VLAN 1, which is a virtual interface, is reachable by all of the switch ports that are up. To verify that I can communicate from the PC to the switch, I'll close the terminal window, open the IP configuration window, and assign an IP address to the PC. I'll assign an IP address and a subnet mask, close the window, open up a command prompt, and attempt to ping the switch. You can see that I'm getting a reply from 192.168.1.10. The ping or echo request was successful, and we can now communicate from the PC to the switch using the TCP/IP protocol. I'd like to stress that since the IP address has been assigned to a virtual interface VLAN 1, that means that it is reachable by any of the switch ports on the switch that have been assigned to VLAN 1. In other words, the difference between the PC and the switch is that the IP address on the PC is bound to the Ethernet port, whereas on the switch the IP address is bound to the VLAN. So, if I disconnect the Ethernet cable from the switch and put it into a different switch port, this time I'll put it into this gigabit Ethernet port, we should still be able to communicate to the switch using the IP address. I'll fast forward time, bring up the PC, repeat the ping command, and you can see that the switch is still responding to the IP address 192.168.1.10. This will work on any of the switch ports that have been assigned to VLAN 1. In this demonstration, I need to verify that the IP addresses 192.168.1.2 and 192.168.1.3 have been assigned to switch S1 and switch S2. These IP addresses should be assigned to the default switched virtual interface VLAN 1 on both switches. To verify this, I'll use a console cable and I'll console in from PCA to switch S1 to begin with. I'll click on the console cable, click on PCA, attach it to the serial port, stretch the cable over to the switch, and attach it to the console port. I'll open PCA, click on the terminal emulation program, click OK, and you can see I now have a console connection command line interface. I'll type enable, and I'll use the show command, show IP interface brief, to examine the switch's interfaces. I'll have to use the space bar to page down through the interfaces, and you can see that the last entry is the VLAN 1 switched virtual interface. It's been assigned the IP address 192.168.1.2 as I expected, but if I look over at this column, I can see that the interface is administratively down. In other words, it's in a shutdown state. As a result, the line protocol is also down. I'll need to turn on this interface. I'll go to Global Config mode, go into Interface VLAN 1, and type the command no shutdown. Instantly, I'm presented with output showing that the interface VLAN 1 has changed state to up. I'll press Enter, Control C, and then up arrow to cycle through my history of commands, and then I'll reissue the Show IP Interface Brief command. You can see that the interface VLAN 1 is now up, physically up, and the line protocol is also now up. To do the same thing on switch S2, I simply click on the console cable to detach it, stretch it over to switch S2, and I can put it in the console port. Now I'll click back on PCA, I'll close the terminal, and then reopen it. On switch S2, I'll type the enable command and the show IP interface brief command. Page down, and you can see that interface VLAN 1 is still unassigned. It does not have an IP address, and it's administratively down. I'll go to Global Config mode with a conft command, enter interface VLAN 1 with an int VLAN 1 command, and put in the IP address 192.168.1.3 and the subnet mask, and finish it with a no shut, short for no shutdown command. The interface is now up. I can verify it with my show command again, and you can see that interface VLAN 1 now has the IP address, it's physically up, and the line protocol is up. To test the connections between all of the devices, as well as the IP address assignments, I'll use the ping command. To do this, I'll click on PCA, click on the command prompt, and I'll begin by pinging switch S1. I'll type in ping 192.168.1.2 and see if I can get a reply. Alright, the first request timed out, but the last three requests, I received replies. If I reissue the command, you can see that I'm getting replies from switch S1. I'll also try to ping switch S2 at 192.168.1.3. And you can see I also get replies. So I verified that I can ping from PCA to switch S1, from PCA to switch S2, and now I'll attempt to ping PCB at 192.168.1.11. I got echo replies from PCB indicating that I have end-to-end connectivity all the way from PCA to PCB. It's a good idea to test the connection from the other side by pinging from PCB to PCA to verify that the communication goes both ways. If for some reason the pings had failed and I was using real PCs, I'd also want to double check my firewall settings and make sure that I had my Windows firewall turned off. Windows firewall will block ping ICMP echo requests by default. On a real network, if you can ping one way, for instance, let's say from one PC to another, but when you try to ping the opposite way, the pings fail, that indicates that one of the two PCs has their Windows firewall activated.